This L'Hopital's rule 4-4, is that the only one we did? All right, so any questions on 4-3, 4-4 about the Lakers? So you guys got my email, right? The drop deadline has been extended to the date that I put in the email. I don't remember what I put, but basically you can take exam 3 and then decide then. Also keep in mind, I still got to include your 5% participation. So that should help a little. I'll do that within by end of this week. So, but if you're not sure if you want to stay in this class or not, I would just recommend that go ahead and stay. You can't hurt. Take exam 3. Worst case scenario, you learn a few more things before you drop the class. But make an effort. You can. A lot of you are doing well, and some of you are close. So keep trying. And all right. So number 15 on which section, Daniel? 4-4. I mean 4-5. That L'Hopital's rule section. Last one.
Yes, that one.
Well, 4-5 was curve sketching. So 4-4, you're thinking.
Yeah, 4-4. Sorry. Yeah.
All right. Did you guys read what happened about the Johnson & Johnson vaccine? I guess they're going to put it on pause, right? Because of apparently there were 6 cases. I read an article where of blood clots issue. Oh, I forgot you guys are not in a talkative mood today. So we're going to plug in t equals 0. And if you plug in t equals 0 here, e to the 0 is 1. So you get 1 minus 1. So you get 0 on top. Sine of 0 is also 0. So it is a 0 over 0 scenario. So we will use L'Hopital's rule and take the derivative of the top, which is e to the 2t, it's itself times 2. Derivative of minus 1 is 0. And derivative of the bottom is cosine of t. Now let's plug in t equals 0. So if I plug in 0, 2e to the 2 times 0 over cosine of 0. Well, e to the 0 is 1, so you get 2. Cosine of 0 is 1, so the answer is 2. And that's it. That was actually one on the easier side compared to some of the other ones.
Yeah, I was just trying to figure out why cosine of 0 was 1, but it makes sense now.
Yeah, because cosine of 0, if you look at your unit circle, cosine is the x value on the unit circle. So there, that's the largest that it could possibly be, 1. Remember, cosine is x over r, so cosine of theta from trig is x over r. So if you're talking about the unit circle, r is 1. So what's the x value here? 1.
All right, thank you.
Anything else from 4-4 or 4-3 that you want me to talk about?
Professor, I have a question.
Yeah.
For in section 4.3, and when we do like when we get the first derivative, I don't know if this is a good question or not, but when we get the first
Probably
derivative,
not. Go ahead. I'm just joking.
and we get the first derivative and we set it to 0. When do we? Sometimes I don't know if I'm overthinking it or I'm just not like looking at it right. But how do we know when to like? Sometimes we'll get like 6x or something. The number will equal 0, but sometimes we don't include it. And
Okay. Oh yeah, I think I know what you're talking about. Okay. So when you're trying to figure out the critical value, find the critical number. Let's say you have a polynomial, and I'm just making this up. After you take the derivative, let's say you get something along the lines of 2x squared plus 10x plus 6. That's one scenario, and I'm going to show you how to set that equal to 0 and solve. So this is after you take the derivative. Now, because the greatest common factor is just a 2, you can just divide both sides by 2. You could factor it out, but the thing is, it's just 2, so you can just get rid of it. If you factor it out, the 2 hanging out on the outside won't do anything. So you could divide it out and just get x squared plus 5x plus, oh, sorry, this was supposed to be a 12. So when you divide by 2, you get 6 equals 0. Then from there, you factor, and you get plus 3 plus 2. So you get x equals -3, x equals -2. Now, it doesn't hurt if you, let's say you decided to, this was a 12. So let's say instead you factored out the 2. So if you factored out the 2, you get x squared plus 5x plus 6 equals 0. So you have 2 times x plus 3 times x plus 2 equals 0. So 2 can never equal 0. So that part gives you no solution. So you still get the x equals -3, x equals -2. So I would not do it this way because you might just, there's no reason to have the 2 there. Now, if the problem was something else, like f prime of x equals 2x cubed plus 10x squared plus 12x. So let's say you took the derivative and this was your derivative, and you're setting this equal to 0. In this case, the greatest common factor is not just 2, it's 2x. It has a variable in the greatest common factor. Then you want to make sure you factor it out. If the greatest common factor has a variable in it, don't divide everything by 2x because you're going to lose a solution like that. So then you get 2x times x plus 3 times x plus 2. So now you have the 2x equaling 0, the x plus 3 equaling 0, and the x plus 2 equaling 0. So here you actually get x equals 0. And then here you get x equals -3. Here you get x equals -2. So long story short, if the greatest common factor has a variable in it, you always factor it out. When it's just a constant, you can do either, but I would just divide by 2 like I did in red here.
Okay, thank you.
Is that what you're trying to ask?
Yes, yes. That's exactly what it was.
Yeah. All right, anything else? All right. Let me have you guys, let's see here, number 33 from the homework. I know some of you already did it. But let's be honest, some of you haven't looked at a darn thing. Do that. Limit is x approaches 0 of x times 3 to the x divided by 3 to the x minus 1.
Professor,
Yeah.
are we gonna have a quiz on Thursday?
Yes.
Okay.
The quiz will cover 4-3 and 4-4. I was going to say that later, yeah. What quiz number is this going to be?
5.
So you should know the, the relative extrema section on 4.3. 4.4 is L hospital, L'Hopital's room. Desiree, what happened? You don't have your first and last name written on your name there. You have your video off, have yourself on mute.
I'm sorry, I just got back from work 2 minutes ago, so
Yeah.
It's unacceptable behavior. Okay, so let's go over this. If you were to plug in x equals 0 here, watch what happens. You get 0 times 3 to the 0 over 3 to the 0 minus 1. So you get 0 over 1 minus 1, which is 0 over 0. So yes, L'Hopital's rule does apply. So what we'll do is take the derivative of the top and the derivative of the bottom. Now, when you take the derivative of the top and bottom, you're not using the quotient. You're treating the top and bottom as if they're all separate functions, separate questions. So the top, you got to use the product rule. First times the derivative of the second plus second times the derivative of the first, which is 1. All over the bottom. Now, bottom is, I was about to use the quotient. I was going to say all over the bottom squared, but now the bottom, the derivative of 3 to the x is just 3 to the x ln 3. The derivative of minus 1 is 0. Now let's try plugging in 0. 0 times 3 to the 0 ln 3 plus 3 to the 0 over 3 to the 0 ln 3. So 0 times anything is 0, so this whole thing is 0. This guy gives you 1, and this is also 1, so just 1 over ln of 3. And just leave your answer as 1 over ln of 3. Do not take out your calculator and try to give a decimal approximation. Don't ever do that in a math class unless the instructions say so. From what I've been told, you do that in engineering. You lie. You just lie. Oh, no, yeah, you can do 0, 0, 0 point. I'll let Shannon explain. All right, moving on. So we're going to go to section 4.5. No, sorry, not 4.5. We're going to skip 4. We're going to go to 4.7. Which is optimization analysis. So in section 4.3, you learn how to figure out relative max min. Section 4 that, section 4 that, you learn how to find out max min. Now, when we're doing that, we're going to do the one section, but before we go to the ones, we're going to do the ones that aren't quite wrong. How to find the maximum or minimum of something. So, best way to explain this is just to just do some examples. So what I'm doing is question number 2 from the books. I think the even numbers to do. And this one is short, and I'm going to write the whole thing out. Find 2 numbers whose difference is 100. And whose product is minimum. That's the question. Do you have any announcements?
No, but we're good for this week. Thank you.
Are there any news? All right.
Yeah, nothing much, Professor.
Okay. So here's what you want to do. In all these problems in this section, you got to come up with an equation that you're trying to optimize. That would be your primary equation. And then you're going to have a secondary equation. So in this case, find two numbers whose difference is 100. So here we go. X minus y equals 100. All right, two numbers that have a difference of 100. Now that's actually your secondary equation. What you're trying to minimize or maximize is your primary equation. In this case, find whose product is the minimum. So you're trying to minimize, I'll use P for product equals XY. So, and you'll get the hang of this. The most challenging part of these questions is coming up with the equation. So after I do a few of them, you'll start getting the hang of it a little bit. I know you're like, why did you come up with that? Well, I've been doing this for a long time. So again, read the question. Find two numbers whose difference is 100. So in this case, we call X and Y dummy variables because they don't really represent anything. Like, for example, if X is so-and-so's age and Y is so-and-so's age, then it's important what you define as X, what you define as Y. In this case, it's just X and Y are two numbers. So X minus Y equals 100, where obviously the way I wrote it, X is the larger of the two, right? Because X minus Y equals 100. And then who have a minimum, and you want to minimize the product. So here's how you do it. What you're trying to minimize or maximize, in this case minimize, you want to write that in terms of one variable here. So what I'm going to do is take the secondary equation, solve for X or Y, and substitute it into here. Now, which one do you solve for? Doesn't matter, but make life easy for yourself. So I'm going to solve for X because it's just a little slightly easier because I just moved the Y over. Then take what X is equal to and substitute it in for X there. So since X equals Y plus 100, I went ahead and substituted in for that. Now, I'm going to go ahead and distribute the Y. Now, where does minimums occur at? It occurs at critical numbers. How do you get the critical numbers? Take the derivative, set it equal to 0. So P prime is equal to 2Y plus 100. So Y is an input variable here. It plays the same rule as X, just the derivative of Y is going to be 1. So 2Y plus 100, set it equal to 0, and then solve for Y. That's how you find critical numbers. So Y equals negative 50. Now, if Y equals negative 50, what is X? Well, let's go back up here. X equals Y plus 100. So X equals negative 50 plus 100. So X equals 50. Now, so far I've gotten Y equals negative 50, X equals 50. The question said minimize. How do I know this gives me a minimum? Well, two reasons. Well, one, it always works out the way you want it to work out. Two, we're going to do the second derivative test. What's P double prime? That's the derivative of the derivative. It's positive 2. When the second derivative is positive, means the function is concave up. So if it's concave up and it's a critical point, so that means it's a minimum, right? So therefore, yes, X equals 50 and y equals negative 50 does give us the minimum possible product. Now, it's a good thing that they set minimum because this doesn't have a maximum. It wouldn't have made sense for them to ask, find the maximum product, and I'll explain that in a minute. So it depends on how they word the question. If they say, find two numbers that have the minimum product, that would be it. If they said, what is the minimum product? Well, you multiply those together. So let me explain to you why in this particular problem, it wouldn't have made sense for the author of the book to ask, what's the maximum product? Just FYI. So let's see here. I'm going to make a little table, X, Y, and the product. So we got, just think of two numbers that where they have a difference of 100. So let's say you have 100 and 0. Do they have a difference of 100? Yes. What's the product? 0. Thank you for helping me. Well, what if I want 110 and 10? What's the product there? 1100. Okay, it's getting bigger. What if I said 200 and 100? They have a difference of 100. 2 and 4 zeros, 20,000. Do you see how that doesn't have a maximum? Because I can just keep making X larger and larger without bound, and Y would just be 100 behind it. So there is no way I can have a maximum because I can make the product as large as I want it to be. You see how the question doesn't make sense to ask for a maximum? Now, can you make it, can you go the other direction? No, because if you want to, like, let's say negative 1,000, and you make this 100 less than it, negative 1,100, the product would be a positive because negative times a negative. So that would be too large as well. So it does make sense at 50 and negative 50, which gives me negative 2,500. I don't see how I can get a smaller product than negative 2,500. So again, this is not a proof by making a table, but at least it makes us feel better about the question. The proof is the second derivative test and the critical number. But just trying to show you, explain to you why it wouldn't have even made sense for them to ask for a maximum. Now, on another problem, they might ask for a maximum, but you do the same exact procedure, but except when you take the second derivative test, it should show that it's a maximum. Does that make sense? Okay, let's do another problem. Again, this table that I made is not part of the question. You don't do it that way. You do it using calculus. This is just for me to kind of show you, so you can get a feel for the problem. Let's do number 4. The sum of two positive numbers is 16. What is the smallest possible value of the sum of their squares? Omar Aguilera, the lighting in your room has turned into Herday's old lighting. And Herday just turns his camera off now. Okay, so you got to come up with your equations here. The sum of two positive numbers is 16. All right, so x plus y equals 16. What is the smallest possible value? All right, so again, you're minimizing. I got to pick a letter. I use Q a lot because another book that I used Q for quantity. Smallest possible value, Q, is equal to the sum of their squares. So what you're trying to minimize here is your primary equation. What you do is you use your secondary equation right here to write your primary in terms of one variable. So I'll solve for y this time. Y equals 16 minus x. Take the 16 minus x and substitute it into y there. And that you're trying to minimize. How do you minimize? Well, you got to find the critical values. Take the derivative, set it equal to 0. Now, some people want to take the derivative now. Some people prefer to multiply that out first so they don't have to. So it's just something that's easier to take the derivative of. Either or. So I'm going to probably multiply it out first before I take the derivative. But let me have you guys finish this. Then I'll do it in 2 minutes. How many of you are done? All right, so if you multiply this out, q equals x squared plus 16 minus x squared, that's 16 minus x times 16 minus x, which gets you 256 minus 32x plus x squared. Combine like terms, q equals 2x squared minus 32x plus 256. All right, don't forget to take the derivative, because some people just said it equals to 0. I'm like, you got to take the derivative. What the heck have we been doing the last 7 weeks? Because critical numbers occur at critical when the derivative is 0 or undefined. So you take the derivative, set it equal to 0, and we get x equals 8. Now, if x equals 8, what is y? Well, y is 16 minus 8, so y is 8 right here. So it's 8 and 8. Now, how do I know this gives me a minimum? Well, let's do the second derivative test. What's q double prime? Positive 4. If the second derivative is positive, it means you got a concave up graph, which means you do have a minimum at the critical point. So yes, x equals 8 and y equals 8 does give you the minimum quantity of the when it's sum of the squares. Any questions on that? Isn't this a lot more fun than writing essays in your English class, huh?
It is.
All right, so this next problem that I'm going to do, I'm getting it from a different book. I like this other problem here I'm going to do. So you're not going to find it. I'm just going to write it all out for you, okay? By the way, are you guys good with this? Can I move on? I'm going to go ahead and write all this out because here we go. A rancher wants to enclose All right, a rancher wants to enclose 2 rectangular areas near a river, one for sheep and one for cattle. The rancher has 240 yards of fencing available. What is the largest total area that can be enclosed? And the picture is provided for you, so I'll draw the picture. Okay, the author of this particular book that I'm getting the problem from is trying to be under the assumption that the cattle and the sheep are not going to go into the river. So you don't need a fence there. They should have said that flat out, but they didn't. So you do not need a fence on the north side of that rectangle because there's a river there. So you really just need to use the fence And they provide help here. They call it, if that's X, then this is X, and this is X, because they got to be the same length there. Okay, so just again, I would be clear on a test. I would just say, hey, there's a big wall there. You don't need a fence there. River, it's not quite clear, because if I was a rancher, I would put a fence there. I don't want my cattle to dive into the river. It's a huge loss. So go ahead and write the question down, then I'll help you. We'll go discuss it. All right, so you guys copy the question down? So just like word problems in general, the hardest part is coming up with the equation. So here's what you want to do. You have 240 yards of fencing. And in the picture in the problem of the book, they already threw the X's in there. So if that's X, we'll call this distance Y. And so what you're trying to maximize is the area of the rectangle. So maximizing the area, which is X times Y, right? The formula for area of the rectangle is width times length, so it's X times Y there. Now I need a secondary equation because I'm trying to use a secondary equation to rewrite that equation in terms of one variable. All right, so what other information have I not used? The 240 yards, right? I have 240 yards of fencing. Doesn't that mean that this fence right here that I have my cursor on, the amount of yards I use here, plus here, plus here, plus here should add up to 240, right? So wouldn't that be 3x plus y should equal 240? And that's my secondary equation. That's going to help me write my first equation in terms of one variable. So you're doing it like a substitution. So you go ahead and I would solve for y here. And then take that and plug it in for y in the other equation. So you guys go ahead and finish this now. Okay, so we got A equals x times 240 minus 3x. So I went ahead and substitute that in for y. Now I'm going to distribute the x just because it's just easier to take the derivative like this. Take the derivative, so it's 240 minus 6x. Set the derivative equal to 0. Solve for x. So x equals 40. Now, if x equals 40, what is y? Well, y is right here, which is the 240 minus 3x. So y equals 240 minus 3 times 40. So y would be 120. So if x equals 40, y equals 120. So the dimensions would be x equals 40, y equals 120. And I labeled what y is, so the person who's grading the paper knows. Now, the question says, what's the total largest area? Well, the maximum area would be x times y. And I'll show you that it's a maximum in a second. So what is 40 times 120? That would be 4,800 square yards. How do I know this does give me a maximum? Well, let's do the second derivative test. What's a double prime? -6, which means it's concave down and you have a maximum. I knew it wasn't the minimum. Minimum would be 0. Don't build a fence. But it's got to be a maximum or something. All right. How are we doing over there? So comparing this to the related rates section, because they're the two word problem sections that we've done. Which one do you like better so far?
This one actually.
Oh, okay. Wait until I get to the tough stuff. Just kidding. All right, let's do one more, then we'll take a break. Number 12. Now, the way this author asks number 12 is they broke it down to an A, B, C, D, F problem because they want you to try to get a feel for the problem. So let me read it to you first. I'm not going to write this whole question down. So if you have your book, turn to page 337. So it says, consider the following problem. A box with an open top is to be constructed with a square piece of cardboard, 3 feet wide by 3 feet wide. Yeah. So by cutting out the square from each of the 4 corners and bending it upsides, find the largest volume of a box largest volume that such a box can have. So then they break it down to part A, B, C. Draw several diagrams to illustrate the situation, etc. All right, so I'm just going to do the problem for you and explain. I'll draw one picture. So you have a box that's 20 by 20. So here's your 20-inch by 20-inch cardboard, okay? So they just say if the side is 20 inches. Well, since it's a square cardboard, they're going to be 20 going all the way around. So here's what you're trying to do. You're trying to use this cardboard and create a box. And the way you're going to create a box is you're going to cut out square corners. And when you cut out square corners, you're going to have base here. Okay, normally I visually show on the graph. Okay. Okay, so can you guys see me in my video as well? Okay, so when I say look at me, I'm trying to show you what's going on. So what happens is you're cutting out. Just look at the iPad first. Right now, you're cutting out these corners, okay? You're cutting out corner here. And when you cut out this corner, what happens is you have this flap that's left over. And that flap, now look at me, what's gonna happen is you're gonna fold that flap up, and you're gonna do the same thing with this flap, and this flap, and this flap. And when you fold those flaps up, you're gonna get a box with an open top. Can you visualize that? Okay, so that's what's happening. Now, the question is, when you do this, you don't need to draw this next one. When you do this, how much of the corner should you cut out? If you cut out too little of a corner, like this next picture, you're gonna have a huge base, but the height of the box is gonna be very little. If you do this, if you cut out a big corner, you're going to have a very little base, but you'll have a tall box. So the question is, how much should you cut out, which is just right, so you can maximize the volume of the box? So do you understand the question now? Yeah. So here's what we're going to do. Since I don't know how much to cut out, the amount we're going to cut out, I'm going to call it X. So then this is going to be X as well, because one side of the box cannot be taller than another. And this is going to be X, and this is going to be X going all the way around. So then this distance right here, going from here to here, is, well, the whole side is 20 inches. So this is going to be 20 minus 2X. Because you cut out X inches from this side and X inches from this side. And same thing going from here to here. That side is also going to be 20 minus 2X. And we're trying to maximize the volume. So that would be V equals volume of a box is width times length times height. So here's the width times the length times the height. So the width, the length, and then the height is the flap that comes up. So once again, if you want to look at the iPad from here, this is the width, and this is the length, which is the same. The height would be this flap that comes up, and you fold it up, and that's X. And that's really the hardest part, is coming up with that. After this, you basically, well, let's multiply it out. 20 minus 2X times 20 minus 2X is 400 minus 80X plus 4X squared, and then the whole thing times X. And then I'm going to distribute the X.
Professor, why is there an extra X on, like, multiplying on the side? I'm just a little confused by that.
This X right here?
Yeah, is that for the height?
Yeah, that's the height. So this is the width, length, which is the same because there's a square base. And then that's the height.
Okay, thank you.
All right, so now can you explain one more time why you chose 2X? Well, 2X because, so this whole side is 20. So if I cut out X inches from this side and X inches from this side, what's left over would be 20 minus the amount I took away, 2X.
Got it. Thank you.
Okay, now from here, you take the derivative, set it equal to 0, and solve for X. So see how much of it you can finish here. hint, you will get two different x values, but just, you can stop after that. I'll help you finish it. All right, so this one requires some algebra skills. So only the people who have had algebra can do this. 400 minus 160x plus 12x squared. We're going to set this equal to 0. So as I set this equal to 0, I'm going to rewrite it in standard form as well. Now, the greatest common factor here is just a 4, so I can divide by 4. So, Robert, this is what you were asking me in class. Because the greatest common factor is just 4, I'll just flat out divide by that. Now, this does factor 3x into x multiplied by 3x squared, two numbers that multiply to positive 100. I'm going to go with minus 10 and minus 10. So look at this. The inner product is negative 10x. Outer product is negative 30x, which adds up to negative 40x. So this part gives me x equals 10/3. This part gives me x equals 10. Now, which one gives me the maximum? I'm going to explain to you. There are two ways you can figure that out. Well, let me wait until you guys catch up on the writing. By the way, you got to be kidding me. I did a different problem than the one in the book. I wrote number 12. We're going to continue doing this problem, by the way. We're going to go with it. I just changed the question on you. The book on number 12 says 3 feet by 3 feet. I did 20 inches by 20 inches. Another book that I use uses 20 inches, so I had that number in my head. But this is perfectly fine. We're just going to go with this problem. So just in case if you're reading questions, how come no one said this, by the way? Okay, so it said 3 feet wide. Did I read 3 feet wide? How come no one said it? And I just put 20. So I read it as if it said 20 inches wide and 20 inches the length of it. So just remember we went by, change the question to just keep that in mind. The side is 20 inches instead of 3 feet. But everything is correct. Okay. Now, going back to the problem, which one of these is the correct answer? X equals 10/3 or x equals 10? Or does it have two correct answers? Well, let's see. Remember what X represents. X represents how far out you go before you cut the corner. If this whole side is 20 inches, would it be possible to go out from here to here 10 inches and then from here to here 10 inches? No, because then you'll have no box left. I can't cut 10 inches from this side and 10 inches from this side. Then there'll be no base left. It couldn't possibly make sense. Whereas 10/3 sounds reasonable because that's 3 1/3. So I can say, all right, cut 3 1/3 from this side. That's 10/3. 3 1/3 from this side. I'll have at least a good something left here. So that's one way you know it's not 10 because you can't have a box if it's 10. The other way you can know that it's not 10 is do the second derivative test. You do V double prime and you plug in 10, you'll see that it doesn't give you a maximum. Whereas 10/3 does. Now, to answer the question of what are the dimensions, well, so it's not 10, it's 10/3. So going back to our original equation here, 10/3 is the height. What's the width? Well, the width and the length are the same. It's 20 minus 2x. So 20 minus 2 times 10/3. That's 20 minus 20/3, which is, let's see, that's 60/3 minus 20/3, which would be 40/3. And the length would be the same thing. So the dimensions of the box will be 40/3 by 40/3 by 10/3 inches. These are the dimensions that will give you the maximum volume. What is the maximum volume? Well, whatever the product is there. 40 times 10 is 16,000 over 3 times 3 times 3, which is 27 cubic inches. Can anyone reduce 16,000 over 27 in their head? Great. Yes, that is correct. It does not reduce. Why doesn't it reduce? I'll explain to you why. This is just an off-topic problem. 16,000 is made up of 2s and 5s, right? 16 times 1,000. What's 16? 2 to the 4th power. What's 1,000? 10 times 10 times 10, which is just 2s and 5s, right? So the top here is just made up of 2s and 5s. The bottom is 3 times 3 times 3. Does anything cancel out? Nope. So it does not reduce. That's just something you can do at a party next time. All right. Any questions? Herday, how come no camera today? I'm hurt. I thought we were on good terms. I mean, I can understand Anahi and Taejun, they don't like me, but Herday, I thought.
I'm honestly having issues with my computer right
Of course you do.
Like, so I have a laptop camera and it's connected to my desktop. So I'm using the software to get it to work.
Okay. I need a longer explanation, please. Thank you. Next thing you know, you're going to give me formulas. All right. I will take a break. We'll start at 4:27. Oh no, her day, I believe you. That was like Damaris, not so much. All right. Moving on. So, moving on to the next problem. So the thing is with these problems in this section is that each one is different. And, you know, it's not like your traditional section. It's kind of like, I mean, the best similarity example I can use is like related rates. Every word problem is different. It's not like, all right, here's the quotient rule now. Let's do 10 problems where you practice the quotient rule. So you got to think about it. And then when you do the homework, I'm going to say the same thing I said in the related rates section. Just, you know, do the best you can. You might know how to do one, and then the next one you don't know how to do. Just look at it for a few minutes. If you can't figure it out or you give up, go to the next one. And even if you could do every other one, that's great. Or one out of every 3 the first round. And then when you do, then come back and try to, again, just you got to put in some time. Don't expect to look at all these and be able to do it right away by looking at it. Even I wasn't like that when I was a student. Aaliyah was like that, but you know, we don't really care about Aaliyah as far as her skills.
It was not like that. I struggled through this section too. But it's better than 3-9.
Yeah, I actually, I'm trying to remember when I was a student. I think I struggled with 3-9 more. The optimization wasn't bad for me. I struggled with 3-9 and the delta epsilon proof. I didn't really get it the first go around either. All right, now let's do number 22. Find the point on the curve y equals square root of x that is closest to the point three zero. So let's hold on. Let's go to graph paper here. So hopefully you know how to graph square root of x. So square root of x, there's 0, 0, 1, 1, 4, 2. So that's the graph for square root of x. The 0.30 is right here. So the question is, what point on this curve, y equals square root of x, is closest to that 0.30? So let's say it's some point right here. I don't know what point that is, but I'm going to assume say some point around there. So we'll call it xy. My goal is to figure out the xy value on that curve that's closest to the 0.30. You guys understand the question? I'm not saying you know how to do it, but you understand what they're asking, right? A simple nod would do. Okay, there we go. So now, so what we're trying to do is minimize the distance. since we're trying to minimize distance, it's the distance formula. The distance formula says d equals the square root of x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared. Now, sometimes people ask, well, what if, do I have to memorize the distance formula? If you know the Pythagorean theorem, you all will be able to come up with the distance formula on the spot without any notes. I'm going to show you a trick. I'll come back to this problem in a second. Let me show you how you can come up with the distance formula. So if you want to know the distance between two random points, what the distance formula is, it's the Pythagorean theorem, you just don't know it. So what you do is you form a right triangle. What's this distance? It's the difference between the x's, right? So the differences between the x's. So that's your x sub 1 minus x sub 2, the distance between the x values. What's this distance? That's the y sub 1 minus y sub 2, the difference between the y's. And this is the distance that you're trying to get. So isn't d squared equal to x minus x sub 1 minus x sub 2 squared plus y sub 1 minus y sub 2 squared? Now, if you square root both sides, you get the distance formula. All right. So are you ready to continue? So this is the point 3, 0. So you got x, y, and 3, 0. So you're going to use the distance formula between those 2 points. So d equals the square root of x minus 3 squared plus y minus 0 squared. Now so what I'm trying to do is minimize the distance, d. But I'm going to create a new function called f of x, and it's just going to be what the radicand is. And here's my logic. Well, y minus 3. If I can just minimize what's inside the radical, I basically minimize the whole thing, the radical as well. Because f of x is what's inside the radical. If that gets minimized, well, the radical gets minimized. So there's no reason to deal with the radical. You see the trick that I did there? Well, whether you saw it or not, I'm doing it. Okay. So let's move on here. F of x, but I'm calling it f of x now because you want to be mathematically correct. You don't want to keep calling it d because now this is not equal to d. It's equal to something else. We'll call it f of x. So you got x minus 3 whole quantity squared. That's x squared minus 6x plus 9 plus y squared. What is y? Let's do, since I'm calling it f of x, I better get rid of y. Well, y is equal to square root of x. So I should have substituted in y before this. Oh, well. X squared minus 6x plus 9. Y is square root of x, so it's square root of x squared. Now, technically, by the way, I made an error here. I really should have substituted in for y over here. Because once I call it f of x, it's supposed to be a function of x, but you'll let that slide, right? So you really should have plugged in square root of x for y like 3 lines ago. Madison, you're shaking your head. You're like, what? Like, it's unacceptable. All right, so square root of x squared is just x. Now, you don't have to write this many lines. I'm just doing it to show you. Now, I combine like terms, f of x equals x squared minus 5x plus 9. All right. Now, take where do minimums occur at or maximums at critical values. So we're going to take the derivative and set it equal to 0. So here we go. The derivative is 2x minus 5. Set it equal to 0. X ends up equaling 5 over 2. Let's see if that makes sense looking at our picture. Yeah, it does make sense. Look, I almost have it at 2.5 right here. Now, if I want to know the point, I still got to get the y value. Well, if x equals 5/2 and y equals square root of x, so y equals square root of 5/2. You can just leave it like that. You don't have to rationalize the denominator. So 5/2, comma, the square root of 5/2 is the point that minimizes it. Now, how do I know this gives me the minimum? Now, a couple things. You know there is no maximum, right? Because the square root of x graph goes on to the right and forever. So you can get the distance as large as you want it to be. So it wouldn't have made sense to say, what's the maximum? So either there's a minimum here or there isn't. So what's doing the second derivative test, what's f double prime? Positive 2, which is concave up. So you have a minimum at the critical point. There we go. Yeah. So this is our answer. This point right here is the point on the curve, which is the closest point to the point 3,0. By the way, when you're doing the homework, number 37, the very last one that I assigned, that's going to be a very tough one. Don't even stress about it. I'll show you how it's done. I probably should have took it off the homework sheet. But let's try it out. See if anyone can get it. You get extra credit. I'm just joking. That's the other problem with the extra credits. Some professors do that. I don't see the logic yet. So sometimes a professor will put a really tough question on a test as an extra credit question. Here's why that makes no sense. Now follow me on this. Who's going to get that right? The person that's really smart that has a 99% in the class anyway. They don't need the extra credit. The person that needs the extra credit, who has a 65%, they're not even getting like their regular problems right. How are they going to get that really tough question right? So basically, it makes no sense to put a brain teaser extra credit question on the test. There's no logic there. You follow me? Hey. I don't know why I go off on a rant. I get like that since being at home in lockdown. All right, let's do another problem. Let's do one more, number 36. And I'm going to go eat dinner. I don't want to see you guys anymore. All right, so here's the question for number 36. A poster is to have an area of 180 square inches with 1-inch margins at the bottom and 2-inch margins at the top. What dimensions will give the largest printed area? Oh, hold on, sorry, I read it wrong. 1-inch margins at the bottom and the sides, and 2-inch margin on top. So here's your poster. So what you're trying to do is, when you have a poster, the area that you're going to print on it is not going to be the whole poster. You want to have like edges where you're not using to print. So they're saying the whole poster is 180 square inches, but in the printed area, let's do here, on top, you're going to have a 2-inch margin. So let's call that 2 inches here, this distance right here. And then on the sides and the bottom, you're only going to have 1 inch. So the red is the 2-inch margin. The blue here on the bottom, you're only going to do a 1-inch margin. And on the side, it's only 1 inch. 1 inch. All right, so let's read this again. A poster is to have an area of 180 square inches. So the whole thing, the black, is 180 square inches. So let's call this X, and let's call this distance from here to here, the whole poster, Y. So that means X times Y equals 180. What dimensions will give you the maximum largest printed area? So the red rectangle, that's the printed area. That's what you want to maximize. Might as well use my iPad. I would never be able to do this on the board, so I might as well use this. All right, there we go. There's the printed area. You want to maximize that amount on this 180-inch poster. So the goal is maximize this area. What is A equal to? Well, the width times the length. What's this distance right here? That's going to be X minus 2, right? Because there's 1 inch on this side that you're getting rid of and 1 inch on this side that you're getting rid of. So it's X minus 2. What's the height? Y minus 3. Because on the height, you're getting rid of 2 inches on this top and 1 inch on the bottom, so that this distance right here on the red is just Y minus 3. From here to here. That's Y minus 3. So that's what you're trying to maximize. So let's go ahead and rewrite this in terms of one variable. Does that make sense? Okay, so let's go back to the secondary equation, which is up there. If I solve for Y, which is 180 over X, I'm going to take that and substitute it in for Y there. So A equals X minus 2 times 180 over X minus 3. So there you go. That's what you're trying to maximize in terms of one variable. So what I would do is I'd multiply that out. Then once you multiply it out, take the derivative, set it equal to 0, and solve for X. Go ahead and try to do that. Lauren, what city are we in today?
Fullerton still.
Oh, okay. Boring goal, Fullerton. I have no idea why the houses prices are keep going higher this last year. I thought we're in a pandemic.
People have to live with each other now and they want a bigger house to get away from their family. So everyone has like their own space.
I don't know if that's the reason. Madison, I need you to do a 2-page report and come back Thursday with an explanation.
As exciting as it sounds to do that, I think I'll have to pass. Unless I get extra credit if I do so.
Damaris, what area are you talking about?
La Habra Heights.
Oh, you know what I don't like about La Habra? I will tell you. I had a friend in college who lived there. It's far from the freeway. You have to take the streets to go there.
Not the 60.
Oh, that's way up there. I took Lambert. This is like 20 years ago. Lambert going all the way. So then he lived in the area where like Lambert and Beach Boulevard. So you're like far from the 91 and you're far from the 57. It's like way out there.
Yeah, mine's in the border of La Habra and Hacienda, so I'm like right in the border of LAOC.
Oh, okay. Aren't you closer to Mount Sac?
Not really. Considering traffic, for some reason it kind of gets congested between Corona and LA. So factoring in traffic, absolutely not.
Yeah, and Fullerton College is a better school. I mean,
Oh yeah.
Look at the math department at Fullerton College, who they have, and who Mount Sac doesn't have.
Pretty much.
I'm going to go over this so I don't fall asleep. I've only had one Coke Zero today.
It's a step down from alcohol, Professor.
A step down from alcohol. Not even close. Coke Zero is not that bad.
Does he use it for a chaser?
All right, so x times 180 over x, the x's cancel out, it's 180. X times minus 3 is minus 3x. So minus 2 times that is minus 360 over x. And then minus 2 times minus 3 is plus 6. There are no like terms. Oh, there are the 80 and the, so you got a equals 186 minus 3x. And then I'm going to change this to minus 360 x to the minus 1. So we're going to take the derivative. So you get negative 3 plus 360 x to the minus 2. I'm going to rewrite it as negative 3 plus 360 over x squared equals 0. How many of you got up to this point at least? So move the 3 over. 3 is the same as 3 over 1. So there's a couple of ways you could do this. Cross multiply. So this product is 3x squared equals this product, which is 360. Divide both sides by 3x squared equals 120. Square root both sides. What's the square root of 120? It reduces to 2 radical 30. I'm not even bothering to give you the negative because x cannot be negative. It's the width of a poster, for God's sake. I don't know why I'm getting that. All right, x equals 2 times square root of 30. Now, what is y? Well, if you go back up and look what y is right here, 180 over x. So y equals 180 over 2 radical 30. Now, the back of the book would probably rationalize the denominator by multiplying top and bottom by radical 30. You could just say 90 over radical 30 here. I just reduced the 2. So x equals 2 radical 30. Y equals 90 over radical 30. How do I know this will give me the maximum? Well, you can do the second derivative test. I'll do that in a second once you guys catch up writing. So the derivative of the derivative, that's a double prime, is negative 7. After you take the derivative, you get negative 720 over x cubed. Notice negative 720 over x cubed, since x is always a positive number, negative 720 over x cubed will always be negative, which is concave down, which means you have a max. Because negative 720 over a positive number is always negative. So that's that. Again, so when you do the homework for this section, do as many of them as you can. I'll put the answers to most of the problems on Canvas for you eventually, but not in the next few days. I want you to try to do as many of them as you can by yourself. The quiz, I told you, will cover 4.3 and 4.4 this Thursday, which is relative max min over which intervals increasing, decreasing, those questions, that section, and then L'Hopital's rule. And then we'll discuss some of the 4.7 questions as well. And then we'll do 4.9 after that, and we're good. We're in week 11 right now, by the way, huh? All right. And then on Thursday, Madison, a 2-page report discussing why the houses where Damaris is at are 100 to 150,000 over asking price. Make sure it's typed, double spaced, no more than ½ inch margin, Times New Roman font. And I want it in English and in German.
Absolutely, yes. Both languages is definitely important.
Okay.
So do I get
And-
extra credit for doing this?
Yeah, sure. which talks about the logic. Never mind. But what are you going to do with that extra credit, Madison? All right. All right. 9. Daniel, is that the only German you know?
Yeah.
All righty. So anyway, I'm done. You can stick around. Madison, 1 second. I got to ask you a question. But yeah, well, I'm done with class.